Hi all, today we'll be discussing the LeetCode problem of the day, count negative numbers in a sorted matrix. Here you are given an m cross n matrix grid which is sorted in non-increasing order, both row wise and column wise. That means each row is sorted in non-increasing order. Same goes with this row and all the rows. And similarly, if you check the columns, they are also sorted in non-increasing order. So now in this grid, you just have to count and return the number of negative numbers. So in this example, if you see, we have 1, then 2, 3, 4, 5, 6, 7, 8. So total we have 8 negative numbers. So the output is 8. In the second example, we have this as the grid. In this we can see we don't have any negative numbers. So the output is 0. Coming to the constraints, m is the number of rows, n is the number of columns. Both m and n will be from 1 to 100. And the values can be from -100 to +100. Now let's go with the approach. So it is straightforward that we can just iterate on the entire matrix and just count how many negative numbers are there. And that will give you a complexity order of n into m. And this is totally fine because n and m are just 100. So n into m will always pass. But in the follow-up, it is given that can you solve it in order of n plus m. So we'll try to solve it in n plus m. So for that, this is not just a normal grid. It is sorted in non-increasing order in both rows and column wise. So maybe we can use this property to reduce our complexity. We see that in the grid, suppose to check this corner. Now from here, if you move to the right, your values keep decreasing because it is sorted in non-increasing order. And similarly, from this point, if you move to the top, you move up the rows, the value keeps increasing. So using this property, you can always find how many negative numbers are there in each row. And let's see how we can do that. Yeah. So first you're at this corner and you see that the current number is negative. So that means all the numbers to the right side will always be negative because the rows are sorted in non-increasing order. So from this, we can say that in this row, there are total 4 numbers. And this value 4, we can get it by subtracting the column length, number of columns minus the current index. So number of columns is 4 and the current column index is 0. So 4 minus 0 will give you 4 negative numbers in this row. So now this row is done. Now you want to move to the top. So you'll go to the top, you'll decrease the row. Now here you see that the current number is positive. So if it's a positive and you only want to count the number of negative numbers. And from the property, you know that if you move to the top, you'll get greater numbers. And you move to the right, you'll get us lesser numbers. So since the current number is only positive, if you want to get negative numbers, you have to move to the right. So from here, you'll move to the right. And here also, you'll see the current number is positive. Then again, you keep moving to the right. Here you see that you have a negative number. So once you have a negative number, then you're pretty sure that all the numbers to the right of me will always be negative. And you can count them simply by doing the number of columns minus the current column number, which is 4 minus 2, which is 2. So in this row, you have counted 2 negative numbers. So yeah, since the current number is negative and you'll just move up the column, you'll move up the row. So you're at here. Again, you'll see that the current number is positive and you only want to find the negative number. So you'll keep moving to the right. Yeah. So you're here. At this point, the current number is negative. So you'll simply count the number of negative numbers in this row, which is 4 minus 3, 1. And again, you'll move to the top because the current number is negative. There's no point in moving to the right. You'll move to the top and you'll see that the number is also negative. Then you'll again count the number of negative numbers in this row, which is again 4 minus 3, which is 1. After this, you'll move to the top again and you'll see that you've gone out of the grid, so you'll stop your iterations. At the end, if you count 4 plus 2 plus 1 plus 1, which is 8, and 8 is the number of negative numbers in this grid. So let's look at this with another example, then it will be more clear. Let me copy this. Yeah. So for this again, if you move to the right, it will always decrease. And if you move to the top, the numbers always increase. So now you'll start here, which is a negative number. And since it's a negative number, you know all the numbers to the right are negative. So you'll simply count it by doing the number of columns minus current row number, column number, which is 4. Next, you'll move to the top. And since the current number is positive, you'll keep moving to the right until you find a negative number. Yeah. So at this point, you found a negative number. So again, you can simply count the number of negative numbers in this row, which is 2. And okay, once you're at the negative number, you want to move to the top. So now you're here. Again, this is a positive number, so move to the right. You're here. Again, this is a positive number, so again move to the right. So you go out of the bound. So at this point, you'll stop your iterations. So at this point, you're pretty sure that you've counted all the negative numbers, because if you check this element, this is a positive number. So if you keep moving to the left, all the numbers are increasing, so you won't find a negative number. Similarly, if you move to the top, all the numbers are again increasing, so you won't find a negative number. So when you come out of the grid, it is sure that you've counted all the negative numbers. So in this example, the count of negative numbers is 6. Now let's quickly code the approach. So first, let me quickly take the m and n variables. Grid dot length, and n will be grid of 0 dot length. So for a matrix, we want to start at the bottom left corner. So I will be m minus 1, which is 0, and j will be currently at 0. And let's also take answer equal to 0, maybe count. So we'll run the loop. So I starting from m minus 1, and the row will keep decreasing. So the bottleneck for the row is, it should be greater than or equal to 0. And for the column, since column is 0 and columns keep increasing, the bottleneck for the column will be j less than n. So while both of the row and column are in bound, now you'll check. So if grid of ij is less than 0, that means if the current number is negative, then you will simply count all the values in the current row. So count plus equal to n, which is number of columns, minus j, which is the current column. And once you have counted this, you will decrease the row. Else in the sense, the current number is positive. So if the current number is positive, you want to move to the right in hopes that you'll find a negative number. So for that, you'll do j++. And that's it. At the end, just return count. Let me submit. It works. Finally, let's do the time and space complexity analysis. So for the time complexity, here we are running a loop where I is starting from m minus 1, and all the possible values of I are from m minus 1 until 0, and all the possible values of j are from 0 to n minus 1. So the total number of iterations this can happen will be the number of rows plus number of columns, which is n plus m. So time complexity will be order of n plus m. And coming to the space complexity, it's pretty straightforward. It's constant because we are not creating any arrays or such, just few variables. I also have the code in Python. If anyone wants to view it, I'll add this in the description as well. And let's catch up in the next video.